Okay, this is one of the value of R. You have got the R is equal 0.0821 liter atmosphere per mole per Kelvin. I mean, in terms of liter atmosphere, this is one of the value of R. Another value of R you can find out. If instead of 1 atmosphere, if you consider pressure is 1 bar, then 1 mole of gas contain, yesterday I have told you, it contain 22.7 liter. Instead of 1 atmosphere, when you consider the pressure as 1 bar, then 1 mole of gas always contain 22.7 liter. So that is why when you put the value in terms of bar, R is equal PV by NT. So pressure you have to consider 1 bar. Number of mole, when you consider 1 mole, temperature is 273 Kelvin at STP, and volume, since it is bar, so you have to consider 22.7 liter. So after calculation you will get the value 0.083 unit will be liter bar per mole per Kelvin. So this is another value of R in terms of liter bar. So which value you have to use in your equation, it depends on the other parameters unit. If the volume is given in liter, pressure is given in atmosphere, then you can apply this value for R. But if the pressure value is given in bar, then you have to apply the R value, this one. So based on the unit of other parameters, you have to choose the values of R. So these two are the value of R. Another value of R in SI unit you will get. These two are the CGS unit in terms of atmosphere and bar. So all these value you have to know, and based on the other unit you have to choose the value of R. So now I give you the SI unit value of R. I mean that will be number 3 in SI unit, and this value is mostly used. As you know, R is equal PV by NT. Pressure in CGS we consider as 1 atmosphere, and 1 atmosphere means in terms of SI unit, SI unit of pressure is Pascal. Do you know 1 atmosphere means how much Pascal? 1 atmosphere means it is 101,325 Pascal, I mean Newton per meter square. Pascal means the Newton per meter square, so you can write Pascal also, you can write Newton per meter square also, and this one you can write as 1.01 into 10 to the power 5 also, 1.01 into 10 to the power 5 Pascal. So N is number of mole is remain same, 1 mole. Temperature in SI unit Kelvin, that is 273 Kelvin, and the volume, as you know, in terms of CGS unit, when the pressure is 1 atmosphere, the volume is 22.4 liter. But liter is not the SI unit, so liter you have to convert in meter cube. Liter means actually decimeter cube. The decimeter cube you have to convert to meter cube. So when you convert it, you have to divide it by 1000. Ultimately, you will get 0.0224 meter cube. 1 mole contain how much? 22.4 liter. 22.4 liter means 22.4 decimeter cube. So if you want to convert to meter cube, then you have to do divided by 1000, then it will convert to meter cube, and that's why it becomes 0.0224 meter cube. So I convert all the units to SI. SI unit of pressure is Pascal, I mean Newton per meter square. SI unit of volume is meter cube. Unit of mole is mole, and the temperature SI unit is Kelvin. So after putting all this value, when you do the calculation, after calculation you will get the value is 8.314. This type of value you will get. This meter square per meter square cancel. Ultimately you will get Newton into meter, mole becomes per mole, Kelvin becomes per Kelvin. Newton into meter means you can write joule. Ultimately you can write 8.314 joule per mole per Kelvin. So this is the value of R in terms of SI unit. So you have got 3 values of R. one is 0.0821 liter atmosphere per mole per Kelvin in terms of atmosphere unit, and one is 0.083 liter bar per mole per Kelvin in terms of bar, and the SI value of R is 8.314. So these are the values of R. All these three values you have to learn and you have to apply it in your numerical. Now another topic, calculation of molar mass of gas from ideal gas equation. From ideal gas equation you can determine the molar mass of a gas. For example, if you consider carbon dioxide gas molar mass is 44, nitrogen gas molar mass is 28 gram per mole, oxygen molar mass is 32 gram per mole. So every gas have some molar mass. So you can determine that molar mass of gas by applying the ideal gas equation. How? As you know, from ideal gas equation you have got PV is equal to nRT, or PV is equal, you can write what is N. N means number of moles, and number of moles is equal nothing, given mass by molar mass. I mean W is given mass, M means molar mass. Given mass by molar mass means number of moles. So that is why instead of N you can write W by M RT, or M is equal, you can write WRT divided by PV. So this is one of the equation by which you can determine the molar mass of some unknown gas. I mean, if you know the pressure of the gas, if you know the volume of the gas, if temperature is given, and if the mass of the gas is given, you can find out the molar mass of the gas. If the gas is not mentioned which gas, then also you can find out the molar mass if you know the pressure, temperature and the given mass. So this is the equation. If you want to determine molar mass of gas, then you can apply M is equal WRT by PV. Now see, PV is equal nRT, or PV means you can write W by M RT, or P is equal, you can write W by V M RT. You know W means mass, V means volume. Mass by volume means what you can write? You can write density also. So P is equal, you can write dRT divided by M, where D represent density, because density means mass by volume. Now you know R is constant, which is called universal gas constant. M means what? Molar mass. For a gas, molar mass is always constant. So if temperature is constant, I mean at constant temperature, since R is constant, M is constant for a gas, if temperature is also constant, that means you can write P proportional K into, P is equal K into D. Why I have written K? K is a constant, and I have written for RT by M, because R is constant, T is constant, M is constant. So for this whole term you can write constant K. So P is equal, you can write K into D, and when you remove K, then the proportional will come, you can write P proportional D. I mean, from the ideal gas equation you can prove that at constant temperature the pressure of the gas is directly proportional to the density of the gas. In exercise 1, question is given, by using the equation of state, prove that the density of a gas is directly proportional to the pressure of the gas at constant temperature. So you can do this question answer like this way. I mean, you have to prove it D proportional P at constant T. Thank you.